Welcome back to another lesson in MCV4U. Today we'll be talking about the product rule. So here we're going to start and we're going to determine if h of x is equal to f of x times g of x. So multiplication of two functions. Does h prime of x equal f prime of x and g prime of x? So really what we're looking for or we're investigating is does the derivative of a product equal the product of the derivatives. So again, does the derivative of product equal the product of the derivatives? And so let's take a look at this. So in this example, we have f of x is equal to 4x cubed, and we have g of x is equal to 2x to the power of 5. Remember in our lesson on derivatives, f prime of x is equal, so we bring the power down. So 4 times 3 would be 12, and then x to the power of n minus 1, and here's 3 minus 1, so to the power of 2. So f prime of x is equal to 12x squared, and g prime of x would be equal to, again, bring the power down, multiply that by 2, so here would be 5 times 2, 310x, and then n minus 1 to the power of 4. So here, if we look at f prime of x is equal to f prime of x, or h prime of x is equal to f prime of x times g prime of x. We see that f prime of x is equal to 12x squared, and we see that g prime of x is equal to 10x to the power of 4. And if we multiply those together, here we have 12 times 10, which will give us 120. And then with the same base, we use the exponent rules, x to the power of 2 times x to the power of 4. Add those two exponents together, it'll be 120 x to the power of 6. And so here, let's see if h of x is equal to g of x times times, sorry, is equal to f of x times g of x. Let's see if that is the same as h prime of x, which we saw equals to 120 x to the power of 6. So here, h of x is equal to f of x, which is 4x cubed, and g of x, which was equal to 2x to the power of 5. We multiply those two together. We see that 4 times 2 will give us 8. X to the power of 3 times x to the power of 5 is x to the power of 8. And so here we see that h of x, if we multiply that first, and then if we do the derivative, so then if we do the derivative, h prime of x, that will give us 64x to the power of 8, 64x to the power of 7. And so here we see that these are not the same. So to answer our question, does the derivative of a product equal the product of the derivatives? And our answer is no, because they do not give us the same answer. The first one gives us 120 x to the power of 6, and the second one gives us 64 x to the power of 7. Okay, so here, the product rule that we're looking at, what we do is here for h of x is equal to f of x times g of x, then h prime of x will be equal to f prime of x, g of x, plus f of x times g prime of x. So again, to repeat, the product rule is h prime of x is equal to f prime of x times g of x plus f of x times g prime of x. Or if u and v are functions of x, then d over dx is equal to uv, which is equal to du over dx v plus u dv over dx. Or we can also write it as h prime of x is equal to f prime times g plus f times d prime. Okay, so let's take a look at a couple of these examples here. So here it says to differentiate and simplify. So the first thing you want to do is you want to make one of these f of x and make the other one g of x. So we have f of x and g of x. And so we can derive that first on the side. So we see that f prime of x is equal to x, or f of x is equal to x squared plus 1. So f prime of x is equal to 2x, and g prime of x is equal to 6x squared minus 1. So here we see that f prime of x is equal to 2x, and g prime of x is equal to 6x squared minus 1. So here, y prime is equal to, again, f prime of x, g of x, plus f of x times g prime of x. Okay, so we sub in what we have. So here we have f prime of x we saw was 2x. G of x is 2x cubed minus x plus f of x, which is x squared plus 1, and g prime of x, which is 6x squared minus 1. So here, let's expand this. When we expand this, we get 4x to the power of 4 minus 2x squared. So that's just distributing this in. And then here, expand this as well. We get 6x to the power of 4 minus x squared plus 6x squared minus 1. Okay, so we can collect some like terms here. 6x to the power of 4 and 4x to the power of 4, negative 2x squared, negative x squared, and 6x squared, and then the negative 1. So our final answer here will be 10x squared plus 3x. So sorry, 10x to the power of 4 plus 3x squared minus 1. Okay, so let's look at this next one here. So again, we have y is equal to 3x squared minus 5 multiplied by square root x. Just a note here, remember square root x. So if f of x is equal to square root x, or x to the power of 1 over 2, if you remember, f prime of x will be equal to 1 over 2 square root x. So just something to remember here as we work through this problem. So again, label one of them f of x and the other one g of x. So here, again, we have f prime of x multiplied by g of x plus f of x plus g prime of x. So here we see that y prime is equal to f prime of x. So f prime of x would be 6x times g of x, which is square root x, plus here we have f of x, which is 3x squared minus 5 times g prime of x, which is 1 over 2 square root x. So multiplying it by 1 times 1 over 2 square root x. Okay, so remember here, we all have a denominator of 1. That's not written there. So they're all over denominator of 1. So here, if we rewrite this, write this as y prime of x is equal to 6x times square root x 6x times square root x over 1 plus, and we multiplied those in, we get 3x squared minus 5 over 2 square root x. And here, what we'll do is we'll find a common denominator. Okay, so here again, we're gonna have a common denominator. So again, bring two fractions to a common denominator. So what we'll do here, we see that common denominator is going to be 2 square root x. So in the first term, we're going to multiply everything by 2 square root x. So we'll multiply this by 2 square root x, and we'll multiply the bottom by 2 square root x. So what that leaves us with is we have y prime is equal to 12x times x plus 3x squared minus 5 over the common denominator of 2 square root x. Simplify this, we have y prime is equal to 12x squared plus 3x squared minus 5 over 2 square root x. And here, again, combine the like terms. Y prime is therefore equal to 15x squared minus 5 over 2 square root x. Okay, so again, the examples that we were looking at before just have two products. So for example, this question that we just did, it was 3x squared minus 5 times square root x, so two products. What if we have product of 3 or more algebraic terms? So here, let's look at the extended product rule. So extended product rule, if we have p of x is equal to f of x times g of x times h of x, then g prime of x is equal to f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x g of x h prime of x. As you notice here, f prime of x is in the first group, g prime of x is in the second group, and then h prime of x is in the third group. So for each one, we are going to derive it at least once in the extended product rule. So here it says use the extended product rule to find the derivative of f of x is equal to x bracket x plus 1 bracket x squared plus 2. Again, here again we can write it if u, v, and w were functions of x, then d over dx of u, v, w are equal to du over dx vw plus u dv over dx w plus uv dw over dx. So another way to think about it as well. So here we can use the extended product rule to find the derivative here. And so if we label this, if we label f of x as, so here again, f of x is equal to x times x plus 1 times x squared plus 2. And so we'll just label these simply as a, b, and c. So x as a, x plus 1 as b, and x squared plus 2 as c. So let's just highlight these as well. So x in yellow, x plus 1 will be in pink, and then x squared plus 2 will be in green. So again, if we remember, if we rewrite that, so f prime of x is equal to a prime times b times c plus a b prime times c plus a b c prime. And so here f prime of x is equal to a prime, which is 1, the derivative of x, which is 1, b, which is x plus 1, c, x squared plus 2, plus a, which is x, b prime, which is the derivative of x plus 1, which again is 1, times c, x squared plus 2, plus a, which is x, b, which is x plus 1, and the derivative of x squared plus 2, or c prime, which is 2x. So here again, we see that these ones that are highlighted are the derivatives of a, b, and c. And so here, if we expand, we get x cubed plus 2x plus x squared plus 2, and then here plus x cubed plus 2x plus 2x cubed plus 2x squared. And so we can collect some like terms here. We have x cubed, and 2x cubed. We have x squared and 2x squared. Here we also have 2x and 2x, and then the plus 2. So here you can rewrite it as 4x cubed plus 3x squared plus 4x plus 2 as our final expression using the extended product rule. So f prime of x is equal to 4x cubed plus 3x squared plus 4x plus 2. Okay, so it says what other methods could have been used to solve this problem? So we can expand f of x first. So what we could do is we could have expanded f of x first, then find f prime, then find f prime of x. Okay, so if we expanded it first in this scenario, so f of x is equal to x times x cubed plus 2x plus x squared plus 2, multiplied the x in, x to the power 4 plus 2x to the power of 2 plus x to the power of 3 plus 2x. And if we just rearrange this, so it went from the highest exponent to the lowest exponent, so x to the power of 4 plus x to the power of 3 plus 2x squared plus 2x. And then we could have done the derivative of this function of f prime of x, which is f prime of x. So that'd been 4x to the power of 3 plus 3x squared plus 4x plus 2. And we see that the answer, either using the extended product rule or expanding first, then finding f prime of x, gives us the same answer. Okay, so let's continue on. And so what we're going to look at now is we're going to find the equation of the tangent line to the curve y is equal to x plus square root x times x squared plus 1 over x at the point 1, 4. So again, if we remember a couple of things, first thing that that f of x is equal to square root x, then f prime of x is equal to 1 over 2 square root x. And we looked at that in an example previously. So that's one thing to remember. And second thing to remember is that the slope of the tangent is calculated or is understood as the derivative of the function m is equal to y prime. So the slope is equal to the derivative of the function. So if we look at this question here, we have y prime is equal. This is f of x. This is g of x. So f prime of x, which will give us 1 plus 1 over 2 square root x times g of x, which is just x squared plus 1 over x, plus f of x, x plus square root x times g prime of x, which is 2x minus 1 over x squared. Okay, so when we're looking at the slope, we really don't need to simplify the expression. So here we do not need to simplify the expression. We just need to evaluate. So just evaluate at the given x value. Okay, so here we see that it's at the point x is equal to 1. So phi prime at x is equal to 1 will be equal to 1 plus 1 over 2 square root 1 squared plus 1 over 1, plus 1 plus the square root of 1 times 2x, or sorry, 2 times 1 minus 1 over squared. So here, when we calculate that, we'll get 1 plus 1 over 2 times 2 plus 2 times 1. So here we'll have 3 over 2 times 2. So that will cancel out. Plus 2 will equal to 5. So we see that m, or the slope, is equal, slope of the tangent line is equal to 5. And so again, we can sub that back into our equation, y is equal to mx plus b, to find the equation. So y is equal to 5x plus b. And we know that it passes through a point 41 or 14, so we can sub that into our equation. So 4 is equal to 5 times 1 plus b. And we see that our y-intercept is equal to -1. So our equation, equation of the tangent line to this curve, y is equal to x plus square root x times x squared plus 1 over 4 at the point 1 over 1, 4 will be equal to 5x minus 1. Okay, so let's look through a couple more examples here. So here this question says to differentiate the function y is equal to the cubed root of x times x plus 1. So again, if we label this a, label this b, again, we understand that we can rewrite cubed root of x as x to the power of 1 over 3. So here, if we write our equation again, y prime is equal to a prime times b plus a times b prime. So a a prime, so bring the value down. So again, the derivative of this function is 1 over 3. And we bring that down, x to the power of n minus 1. So 1 over 3 minus 1, which is -2 over 3. So here we can write that 1 over 3, x to the power of -2 over 3 times b, which is x minus 1, plus a, which is the cube root of x, times b prime, which is just 1. So here we can rewrite it as x minus 1 at the top of the numerator, and at the bottom, we have 3x to the power of -2 over. So it becomes a positive exponent because it's at the bottom, power 2 over 3, plus 3 square root x. We can rewrite x to the power of 2 over 3 as a rational. So it'll be x minus 1 over 3 cube root x squared plus the cube root of x. And so lastly here, it says find the values of x where the tangent is horizontal. So if the tangent line is horizontal, that means that m is equal to 0. So the derivative function that we found was minus 1 over 3 times the cube root of x squared plus the cube root of x. So we can make that all equal to 0. So 0 is equal to x minus 1 over 3 times the cube root of x squared plus the cube root of x. And if we move one of these functions to the other side, so we'll move 3, the cube root of x, to the other side. And so we have negative cube root of x, and this is all over 1, is equal to x minus 1 over 3 times the cube root of x squared. And here we can simply just cross multiply. And when we cross multiply, this will simplify to -3x is equal to x minus 1. So -3x equals x minus 1. Move the x over, we get -4x is equal to -1. X is equal to 1 over 4. So Again, the values where the tangent is horizontal, is when x is equal to 1 over 4.